Hello everybody, my name is Abhishek Patel and these are my results for the extra credit assignment. This was the system that was provided to us. It has a triple subsystem built in of mechanical, electrical, and thermal. The objective of this assignment was to understand the interactions between the mechanical, electrical, and thermal systems while applying the concepts we learned throughout the class. Step 1 was modeling the system. The first thing I did was I labeled each component with its variable and I labeled each system with a number so it would be easy to calculate. These were the inputs that were given to us. The outputs were also provided to us. And these were the states that I labeled, with the velocity of the mass being x1, charge across the capacitor being x2, and temperature of the thermal subsystem being x3. For the mechanical subsystem, I used free body diagrams to calculate x1, and power loss was calculated using P is equal to IV. P is equal to IV was also used for the electrical subsystem, but to calculate x2 dot, I had to use KCL and KVL rules. For the thermal subsystem was the energy balance from all the power losses being is E in, and the only E out being the ambient air temperature, which meant that everything else was stored within the system. These were the state space equations that I found at the end of the modeling. So that brings us to step 2, which was simulation of the system. These were the initial conditions that were provided within the assignment, and these parameters were also provided to us. This was the code. I used what was provided to us through examples to put together this code. If you need time, please do pause. And the code gave me these results. My substantial insight, according to my results, was that since they all reach a limit, it would mean that the system has come to equilibrium with the ambient air temperature. Thank you so much for listening.